Here's a sneaky radical equation that it doesn't look like a radical equation, but it is. And what you have to remember is that this exponent right here, which is a fraction, means it's a radical. And what I always recommend is when you are looking at an equation with a fraction in the exponent, change this thing to a radical equation with the familiar square root sign and see if that helps you figure it out. To do that, you have to remember this formula, which is that x, or anything, I'll just use x, to the m over n, okay, that's my fraction, m over n, equals, you take x to the m, and you want the nth root of it. So you see the m on top of the fraction in the exponent becomes the exponent, and the n becomes the index of the radical. So we're going to use that to rewrite this equation. I have negative 48 equals negative 16 minus 2. Okay, now we're going to use a radical sign. Inside the radical goes phi minus 4. And remember what m is. It's this little bitty part up here at the top of the fraction. That's going to be a squared. And remember what n is. Let's work this out here. N is the bottom of that fraction, which in this case is 3. So we're going to use that as the index of our radical. And now, for me anyway, this is easier to deal with. First, I want to isolate the radical. Remember, that's always one of our very important steps. So you isolate the radical sign. And once it's isolated, we can get rid of it much easier. So I'm going to add 16 to both sides. And that gives me negative 32 equals negative 2 times this radical, which is the cubed root of phi minus 4 squared. And to keep on isolating the radical, I have to divide each side by negative 2. So let's go ahead and do that. 32 over negative 2 is just 16. And that equals the cubed root of phi minus 4 squared. Okay, so it is time to get rid of that radical. And at this point, let's just keep it simple. Unfortunately, that means we're going to get some big numbers. We're going to cube each side. There are other ways to handle rational exponents, but I want to be consistent with how we've been doing things so far in this unit. I'm going to cube each side, and what that means is the cube exponent cancels out the cube root, and on the right side, we're just going to have a nice phi minus 4 squared. Okay, and that equals something that's not so nice. Let's see, 16 to the cubed is not one I have memorized. That is 4,096. Okay, I don't know why I wrote it down there. Get up here. Okay, so 4,096 equals phi minus 4 squared. So at this point, let's just take the square root of each side. Okay, we can take the square root of each side just like we take the cube of each side or the square of each side. But there is an important point to remember. When you do the square root of each side, what you're really doing is the plus or minus square root of each side. Okay? When you're the one who introduces the square root symbol, it has to be a plus or minus. But if I'm walking along and I see a radical equation just sitting there, and it doesn't have a plus or minus, that means it's a positive square root. So that's an important point to remember. When you make the square root sign, it's a plus or minus square root. So what's the square root of 4,096? Also one I do not have memorized. So here we go, 64. So that's plus or minus 64 equals plus or minus phi minus 4. Now, we don't actually need plus or minus on both sides because, well, you can imagine dividing by a plus or minus. It won't matter. You're still going to have a plus or minus on one side. So plus or minus 64 equals phi minus 4. That means, just rearranging it a little bit, phi equals plus or minus 64 plus 4. I added this 4 to each side. So that's going to give us two possible answers. One of them is positive 64 plus 4. The other is negative 64 plus 4, which means, as our solution, phi equals 68 and negative 60. We have two solutions for this equation.